a new line. We're gonna learn how to graph exponential functions. Woohoo! I don't know if I could stay in this thing.
I keep a close watch on this heart of mine. I keep my eyes wide open all the time.
Yeah, that's not gonna work, is it? All right, so you should have the notes. It's on my blog, but if you don't have a printer, don't sweat it. Just grab a piece of notebook paper and, write little notes as we go along. And hopefully this is another easy topic for you. So we just finished doing quadratic functions. Quadratic functions, those were when it was x squared, right? So the base was the variable. But now we're going to get into exponential functions. That means the base is not the variable. It turns out the variable is now the exponent. Ooh. Exponential functions are really useful. Perhaps you've heard the news that, there's a virus going around. Yeah, crazy. It's exponentially growing. So this is more useful than I could have ever imagined for our everyday life. All right, so getting the pieces picked apart. The A in front here, this is going to be called the initial value. Initial value. All right, think of it, well, it's the y-intercept. So when we start doing some graphs here on the next page, that is where it crosses the y-axis. And if you've forgotten what the y-axis is, no worries. The y-axis is that vertical one. So the A in front lets you know where you are on that y-axis. Then you've got B. Think of B for base. All right, so that's going to be your base. The base is a big player here. The base is going to let you know if it's growing or if it's decaying, right? Growth or decay are your two options. So if B is greater than 1, it's going to be growth, right? But if B is a fraction from 0 to 1, so let's say 1/2 or 3/4 or 0.22222222222, there you go. That would be an example of something that's decaying. It sure would be nice if this virus, this whole pandemic would start to decay, right? I want my life back, don't you? This K right here, this is going to be important for later. It's going to let us know the asymptote, so we'll come down to that in a minute. When we start graphing, we're going to use our table of values on our calculators to get 5 points. We're going to draw in the horizontal line for that asymptote. All right, horizontal means flat. Then we're going to pull out the points and connect it with a curve. So getting into what the asymptote is. The asymptote, maybe I should just go ahead and make that transition. All right, so the asymptote, this is a line, a curve approaches as it heads towards infinity. All right, think of it as an invisible electric fence. What happens if you touch it? That's right, it's not a pretty sight. So you want to stay away from the asymptote. Don't touch it. All right, your graph is going to get closer and closer and closer. It's like, I'm not touching you, I'm not touching you. All right, that's what an asymptote is. The asymptote is always given by the equation y, because it's a flat line going through the y-axis, horizontal line. So it's going to be y equals the k. So that's where k up here comes into play, right? This is going to tell us where that invisible fence is, aka the asymptote. I always spell it wrong. Let me see, A-S-Y-P, silent P. Asymptote. It's almost like a bad word. Asymptote, oh my gosh. All right. If there is not a number added or subtracted at the end, so it's just AB to the x and then there's nothing that follows, think of it as an invisible 0. So your asymptote would just be y equals 0, and in that case, that's the x-axis. All right, I know it's a little fuzzy right now, but once we do a few examples, it should start to pop into place. So right down here, it's just giving you a quick overview, a little side-by-side of what these graphs are going to look like. So your base is greater than 1, so notice we've got growth. All right, so this graph is going up. All right. This graph technically is going up, and you're like, what? No, it's not. I know what you mean. But it's increasing exponentially on the negative side of things. So it's like the mirror image, right? The reflection, if you will. Whereas down here, this is where your base is smaller than 1. So your graphs are going to decay. All right, and this is also decay just flipped down, right? A reflection. So if A happens to be negative, right, when it's less than 0, if A is negative, right, it's going to flip this picture down. All right, so that's all it's doing, is it's taking it and flipping it. Alrighty, so your domain on all of these, it's going to be real simple. Yum. All right, all real numbers. You can put anything you want in for x, so there's not any restrictions there. Just like with quadratic functions, we had all real numbers going in. The range, though, is going to play a different story. The range is going to be based on that asymptote, right? That electric fence that you can't see. So you're going to be watching out for it. If it is growing, then that means your range is greater than the asymptote k. All right, if it's going down this way, you would say your range is less than, right, going down, less than whatever that k value is. Okay, and then this one, your range, let's see, it is technically going up on that y-axis, so we would say y is greater than whatever the asymptote k is. And then for the range y-axis, it's going down, so this would be y less than k. All right, don't let that throw you. Again, I'm going to show you some real solid problems with numbers, and that should help it fall into place. All right, so just remember on this side here, domain, that's describing all the x values in your picture, and the word range describes all the y values. All right, so range, you can rewrite the spelling of that if it helps. Range. All right, so range, you're looking at the y-axis values. All right, so let's look at some of these real quick. We've got y equals 3 times 2 to the x. All right, let's start over here with some of the information before I get to my calculator. The a is the first number, so 3. B is the base. All right, so what's the base of the variable here? The base is 2. All right, so if our base is 2, that means it's going to be growing. Your domain, you don't have to worry about. It's that all real numbers, and you can do that fancy symbol if you want. All real numbers. And then we'll come back to the range in a minute once it's graphed so we can really see it. The asymptotes, so let's see. There is nothing being added here, right? So your asymptote is just going to be at that y equals 0 line. So right here, if you look at it, y equals 0 is right here on the x-axis. Whenever you graph an asymptote, please make it a dotted line, right? We're going to make it a dotted line. It's that invisible electric fence. We don't want to touch it. Nope. All right. So grabbing our calculators, and if you don't have a calculator, you can just type it in piece by piece. But if you've got the technology, why not practice on it? You'll hit the table button and you'll edit in your function. You've got 3 times. I'm going to put parentheses around my base here just to make it pop. So you have 3 times 2 to the x. All right, so to get that little exponent spot, I hit this little key with the blank box. All right, that lifted me up right there. All right, so we will tell it to start at -2, and we'll go by ones every time. So here we go. So at -2, the output is 3/4. At -1, the output is 3/2. At 0, the output is 3. 1 is 6, 2 is 12. All right, so this 3/4 and this 3/2, I don't know, I think it's easier to graph when it's a decimal. So if you type into your calculator 3 divided by 4, for example, you can turn it into a decimal that way. All right, so this is the same thing as 0.75. This would be the same thing as 1.5. Okay, so to the graph we go. We're going to go left 2. Then we're going to go up 0.75. So it's like almost to the 1. All right. Now we'll go left 1 and up 1.5. 0, 3. 1, 6. and 212. See how fast it jumped there, right? That's exponential growth for you. It starts off real slow, right? Only one person has coronavirus, and now all of a sudden, boom, it explodes. It starts doubling, right? 3 times 2 is 6. 6 times 2 is 12. So guess what the next number would be? 12 times 2, 24, and then 48. And it just keeps growing faster and faster and faster. All right, so as you connect these points, be careful, right? It is technically going straight up, but as we come down, remember this electric fence that we drew here, this asymptote, we can't cross it. We can get closer and closer and closer, right? See how close I am? But I'm not gonna cross it. So this is what this function looks like. All right, so as far as the range goes, range is describing the y-axis. We're using everything that's greater than 0, right? It's going to keep on going up and up and up on the y-axis. It's going to keep growing. So my range is everything greater than 0. All right, let's try another one. We have 5 times 1/2 to the x. Okay, so notice, oh, I didn't point it out. Right up here, notice the a was 3. That's your initial value. That's exactly where it crossed on the y-axis. All right, so that number right there is where it crosses on the y-axis. So when I look at this one, 5, I know before I even get into the graph that 5 is gonna be right here, right? My y-intercept, my initial value. Anywho, a is 5, the base is 1/2. Since my base is a fraction now, smaller than 1, it's gonna be decaying. Right, it's going to be getting cut in half every time. Cut in half, cut in half, cut in half. Whereas this one was double, 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 double. All right, so cut in half, cut in half, cut in half. Domain is going to be all real numbers. My asymptote, again, there's nothing being added here, nothing. So my asymptote is just y equals 0. So let me go ahead and come down here and dot in my electric fence. All right, so that asymptote right there, let's dot it in. Okay, so to the calculator I go. We go to table. We're going to edit this guy in. We have 5, and this time it's 1/2 to the x. All right, and we're going to have our table start at -2. And let's get those outputs. All right, so at -2, the output is 20. At -1, the output is 10. 0 is 5, but we already knew that. At 1, it's 5/2, and 2 is 5/4. All right. Again, there's that 5/2 and 5/4 if you prefer it as a decimal, which I recommend for graphing purposes. This is 2.5. And then 5 divided by 4, you could type it in real easily, and you've got your 1.25. All right, so graphing. We have -220. Woo, way up there. -110. We already graphed 0, 5, our initial point. 1, 2.5. And then 2, 1.25. All right, so notice it quickly starts to decrease, aka decay. And it'll get closer and closer and closer to that electric fence, but don't cross it! You'll get electrocuted! All right, so to answer what the range is, the range, the y-axis, we're using everything north of the negatives, right? So we're going above 0. So y is greater than 0 for my range. We don't want it to say equals 0, because if we hit 0, you've hit the asymptote, and that's not good. All right, let's see if we can't get one more problem in here. I think these videos have a 15-minute time limit, so I'll probably get cut off. You can always go and look at my answer key to see all the finished results. All right, so your A, your initial point is 5. Your base attached to the variable is 2. And notice this time we actually do have an asymptote. So this asymptote is going to be at y equals 2. So I'm going to go ahead and get it in here. Y equals 2. That's where my invisible electric fence is going to be this time. All right, so back to it. Since my base is 2, that's going to be growth. My domain is all real numbers. And now I got to see what's in my calculator.